Welcome to the lecture number 30. This is the last week for the MOOC on peer-to-peer network. So in this week, we'll be looking at anonymity, how this actually can get achieved. So before moving on to formally to Tor system, the onion routing system, I am going to describe you one very simple thing which is very basic, and this is what essentially being used in a different form when the Tor routing is implemented. But before moving on to that, if the Tor can be actually used by all of you, you can go to torproject.org and you can download this particular application for yourself and use it. So this does allow what we call anonymity. So the tool this is very popular now, we call it Tor browser. This is basically a Firefox build which actually has been modified to implement the Tor routing. So technically this Tor routing can be implemented in any application. So both endpoints will become anonymous to everybody else. Okay, so when the traffic is passing through, or no intermediate nodes will be able to figure out, it's almost impossible. I am actually telling almost because it is technically feasible to figure out if you have access to all these intermediate nodes, which is what makes it very difficult. Okay, and the Tor stands for the onion routing. That's a short form for this. So a lot of people use it. So in a network, if you actually are running a Tor browser on your machine, this normally will use many machines in between before it exits, and then it can go to the website and access the website. So website will not be able to figure out that you are accessing, who is accessing the website, unless you explicitly tell him that who you are. Okay, so if A tells the website that I am A, then only W will know that it is A, but A knows where is W. So this is a normal internet actually, but this is what is a Tor system. So you are using intermediate nodes which are set up by volunteers all across the world. So your request is getting hopped through this. None of these guys will be able to identify what you are happening. So there is going to be heavy encryption which is being used, and the only way somebody can figure out, either if you are actually knowing this particular traffic, and when you are transacting and this can be cracked, W will be knowing who the A is, so there you can figure out. But by figuring out what is the traffic exiting from your node, nobody can figure out where you are communicating. Okay, so this is a very powerful tool, and in fact there is an extension to this. We will be discussing even that at some point of time. So where not only you you are in this Tor network, so there are services which are also in the Tor network. So these services you will be able to access through splicing these two kind of relay connections. So you will not be knowing where this guy is, where this server is running, and you can get the service. These are what we call darknet websites. So that's a popular name. So you will not be knowing that where these websites are there. Facebook also runs a darknet website, so you can actually access your Facebook from there. Okay, so you go and search for the darknet URL for the Facebook. I will tell you what is that particular URL, and you can try that and access it. So this is a very nice tool, and of course in this browser you can see that what are these relay nodes which are being used. Okay, now these all set of nodes, they actually all form peer-to-peer network. So you can always decipher where these nodes are, and they always remain connected as an overlay network. They all use similar any one of the DHT routings to maintain the network connectivity. So but before going into these details of Tor, which I will be doing in next few videos. So let's look at one of the most basic systems. So here what I want is, now remember these, when I am talking about these Tor systems, I am talking about TCP connections, transport control protocol. These are not packet based systems. These are likely directly TCP messages. So though of course you can use packets in between for relaying, but there is end to end, there is a TCP connection. So whatever your bytes you are pumping in, these bytes are going out here. You don't have to attach any message or any overhead or anything, but technically yes, these are actually messages which are being transported among this, but the endpoints, so this is the exit point from the Tor network. This is what we call Tor network, and these are called Tor relays, and this is the exit node. So from there it goes to the internet and accesses the website. Okay, so and when this darknet websites and everything, they are actually all part of Tor network. It's very difficult. In fact, in some of the countries this is actually illegal to use, but it's very difficult to crack, very difficult to track this particular situation. So I am now first of all describing how a packet switching system actually can be built in this fashion. So I am basically giving a scheme. We call it a telescopic encryption mechanism. So that's what essentially I want to explain here. So A wants to talk to some node. So we call it, say, S actually want to talk to D. So let me have this. So we also have nodes A, B, C and D. We have 4 nodes, so the message can go through this way and ultimately to D. Now we are not going to use IP based routing. So no IP routing. We will be using DST routing for all messages to be transported. So it's a DST message which will be transported. In DST message, you don't require a source node to be there. So you can send a message without source node. So no source node. So there is a reason why I am actually doing it. Of course it is possible, but there is no source node to be done. So when a packet goes from source to A, so A will only know there is some destination node. So A will go to B and B will go to C and C will go to D. Now the problem here is, what I want is A and D can know, S and D can know each other, source and destination. They can know each other's node ID. Okay. But these intermediate nodes will not be knowing which are the two people who are communicating. They may know the other person, but they may not know the both of them at the same time. So in fact, B, for example, will never be able to figure out who is communicating to whom. It only at best may know that only A is communicating, but A also it will not be able to figure out in the current scheme, because source node entry is not being maintained in the packet which is being transmitted. Okay. So, and D will be the final goal where the message has to go. Now let's see what's the message for C, how it will look like. So there is a message which I want to send to D, I call it message to D. So now this message, S has created this message just to go to D. So what it will do? Now somehow C should know that where is the destination D, then only this can send the message. So I will create this particular message, but then this message is for D, and most likely I can actually encrypt it with the key. So I want to do it that way. Now one more important thing, that I am actually taking a case where public key and private key pairs are there with every node, and public key is used as a node ID, or maybe hash value of this. This is also possible that you can compute the hash and that becomes a node ID, but then you still maintain the public key. So any node ID will be going to have a node ID, public key, and of course the signed hash. So you can always verify this signed hash with this public key. This verification is possible, and because you can verify the public key, this signed hash, so you know this node ID is actually randomly generated. It's not any arbitrary thing. And of course this also serves another purpose, to provide anonymity or security. So I will take some key and will actually encrypt the message for D by key. So let me write it in a slightly different way. So I have MD. This is going to be encrypted with keys. That's what I am showing with this. Okay. Now what I am going to add here is I need to tell. So D knows that it is being encrypted. So key will be now encrypted. Key has to be added, and this will be encrypted with the public key of D. So key still is not being mentioned here. So D knows that it is going to come with me, and it has to be told that there is no further destination to whom you have to send the packet. So I have to also tell this guy that when D receives this packet, he gets this key, he gets the message, but he should also tell whether it has to be for whom. So there should be a node ID of this is for who is the next guy to whom it should be given. So once I tell you are the person to whom it is given, it knows that I need not forward, it is actually for me. I can decrypt the key and then get the message. Okay, so it will now put the node ID. So I call it node ID is D. So this is the node ID for this particular node. So that is what is going to be put. This is the whole message. Okay, and then the message should contain that to whom it is to go back. So when it is the original guy, so I need to tell. So now this will be encrypted in this particular message. This will consist of message plus the source to whom you have to respond. So nobody else will be knowing who is the source unless it goes to the D. D will decrypt everything and will know it. This information will tell that it is not to be forwarded to anybody. Now this is the message which should come out and should become available to C somehow. Okay, so this is going to be the message which has to be there with C. So now this message when will be received by C. So C has to receive this message. So C somehow should actually know now this whole message to whom it has to be forwarded. Okay, this message D also should also have source, plus it should also have a destination, also should be incorporated in MD. So let me just put it here. So I should also have a flag whether it's forwarding or not forwarding. I can do it this way, or I can actually put a node address. This is a destination, this is a source. Okay, this is incorporated. So when D will be received, so it will be decrypting everything. MD will be available for D. So from that it will figure out that this was generated by this, has to be forwarded to me. This is actually my message and I have already successfully decrypted this one, and this is a source to whom I need to respond. So this actually is becoming part of the message itself. Okay, so once I get this, I am now here also adding this node ID D. So this is the message which should be sent to C. So when C will receive this, he will figure out what is the node ID to whom I have to forward it. This it cannot do anything. It will simply now forward this particular part. It will just simply forward to the node D. This is all anyway encrypted, so nothing will be happening. Only D can decrypt it. So from C it will now go through DHT hops and ultimately reach to D. So D will only know that it has come from a node which was the previous hop. It will not be knowing about C because there is no source address anywhere except in the end where it has been put here, so that D can respond back to the source. Okay. So D will only be knowing at best this is the previous hop from where it comes. So it has to have access to everybody to know actually from where the message actually has arrived. So once it knows C, and that's it. Until C everything is encrypted actually. Now this MC also has to be further encrypted actually. So the way it will be done is this MC will be taken. So MC is a decrypted message. So MC will also be encrypted by some key. So I can call it key C. And key C will be present, and this will be encrypted with the public key of C. So only C can decrypt this one, nothing else. So this is the message which is coming encrypted. Okay, and so MC will be done this way. This is now what I am creating is MB now here, and plus because it has to go to C, the node ID. So this is the message which will be coming to B. So when it comes to B, B will figure out to whom it has to go. It can't decrypt all this stuff, but it has decrypted the message which has come. So for example here, when it is received by C, this whole message, MB will only send this much to the C actually. So C will figure out, will decrypt using this particular key will be decrypted first using the private key, and this key will then be used to figure out the MC. And MC contains where the message has to be forwarded now, which is D, and what's the message which has to be forwarded, which is further encrypted. So there is a multiple layers of encryption which are happening. So similarly now going further, so you will have now MB here, which will be encrypted with, when it will be coming, it will be encrypted with key, which is, so only B can decrypt this particular message, that's why it's encrypted with key B. So there is, this key will be encrypted with the public key of B. Only B has the private key, so only this guy can actually get this MB message, nobody else. And when I add B here, this is the message which will be received by A. Okay, and of course, when you look at MA, this will be further encrypted by another some random key. And now this whole exercise I will explain where it will be done. So I will add key here, which will be encrypted by public key of A. So only A can decrypt using the private key, this particular key, and which can be used to get the message A. Okay, now this message is what is going to be generated. So this message has to be sent by whom? So you don't require anybody here. S already knows that I have to give it to A. So this is what the MS, the node which is transmitting the source here. So this S will generate this particular message. Okay, so important thing which you have to note down, that here I don't need any other information. This is not required. Okay, because S anyway knows, S knows that which are the A, B, C, D nodes, and the last guy D knows about the source. So that's very important. So the procedure here is very simple, that A will now, the source will choose, it will have a routing table, and routing table is maintained using logarithmic partitioning again. It can have even other node list also it can maintain. So there, if there are even 100 nodes, okay, and it has to choose these 4 guys which are very, very different, you will get the way the sequence, you can actually do 4 combinatorial, so 100C4 possible combinations exist. So it can choose any combination of A, B, C, D, and S will then start creating this particular thing. It knows what message has to go, so it will pick up the message which was to be communicated to D, okay, which will be now this message which has to go to D. Okay, so this message is going to be this, it will add its own node ID. Okay, then it will add D, so that D knows that this is the next hop to whom it has to, or it's basically going to be a flag. It can simply be a flag, no more forwarding. Okay, and when here there will be again there will be a forwarding of flag will be there. So D can be there and D can pick it up when D is there. So there is a forwarding flag, so it will be forwarded to D. So D will be staying here. So now S will start creating this procedure, this from this message onward, it will keep on creating first layer, choose some random key, encrypt with the D, because now once S knows all these guys, S also knows what is the public key of A, public key of B, because it knows all the node IDs. So S knows all these. So it will use these actually one after another and it will create an encryption layer. Okay. So now the way it looks like, you are going to have a encryption layer from source, but this is going through multiple hops. So by the time it reaches A, okay, A will not be knowing that where is the S, because S is not listed, it's just going through multiple hops. So at best A will be knowing only this previous hop. And here A will be now decrypting or removing one layer of encryption, and you will have another layer, it will go till B. Okay, B again, this will be going through multiple hops. So A only knows that it has to go to B, it's not aware that it has to go to D actually. Okay, so B will only know the previous hop, it is not going to know that it has come from A. So B can decrypt it, so there is another encryption layer gone, and again C will be there, again it has gone through multiple hops, another layer will be removed, and ultimately it will be D. Only D knows it has come from S, because that S is being mentioned in the message. If you don't mention it, D will not be knowing that it has come from S, only thing a message has come. It has to make sense out of it actually. It only knows about this previous hop from where the message has come. This is what we call telescopic encryption. Which is used. This is actually very safe because of multiple layers of encryptions which are used. Now this is kind of anonymity because no intermediary will be knowing, and for every message you can choose a different intermediate nodes. So if your destination is fixed and remaining 100 nodes are there with you, so 100C3 combination, which itself is going to be still very large, it's not a small number, and keep on changing it every time. Only problem is that if you are in a network, what is going to happen is you transmit, if this is your A, this is your B, and this is your D. Okay, normally if you would have done it, would have been very efficient going directly here. But now the way it is happening is, you are not even going directly to A now here. You are actually going through DHT hops like this. Okay, so you will never know you are going which hops, and you are reaching to B. And then you are reaching D. So you are actually creating a mishmash essentially. So it becomes kind of extremely inefficient, but that's a penalty which you have to pay when you want to have anonymity. Another way people thought in the beginning anonymity can be done was using anonymizers. So there is only one server which is there, and then there are nodes. So somebody wants to talk to somebody else. So then what you do is you actually then send a message to anonymizer box, the server, and this server will remove the source IP address or whatever is identifier and will send it to the destination. So everybody sends a packet to anonymizer telling that to whom the packet has to go. Okay, everybody will send it to only, this is like a proxy, and it will remove the source, so they will only know the packet has come from anonymizer. Only problem is if this gets compromised, everything gets there. If this fails, anonymous service fails. This is not what is going to happen here in this case. Okay, so this is the very basic of how the anonymity can actually be built. Now the next question arrives, how the D is going to respond back. So the way it is going to happen is that S has through A, B and C, actually it's not a direct connection, it is a multiple hop, so that's the way I should show it, not by a straight line. I'm removing that part. So it's better to show it this way. So that's the way. Now D knows where the source is, so it can actually now pick up another set of nodes, its own, maybe X, Y and Z, and then the message will come. Now only S and D should now have only powers to tell, can mutually do authentication, so they can know each other. So two friends can talk to each other, but nobody can do traffic analysis on the internet and can find out who is talking to whom, and you are every time can keep on changing these pairs. So this basically is one of the ways that anonymity can be done. So next video will look into how the Tor browser or Tor routing works, and it is basically trying to create what we call TCP connections. Okay, currently what I have told you is a packet based system. message is being done. In fact, now you can create variety. Here you have only what we call forward secrecy. Okay, so when A sends to B, B will not be able to figure out it has come from A. It only knows about the previous hop. That's a forward secrecy. Okay, but A does know that it is going to B. Now, how to figure out that even forward as well as backward secrecy both can be achieved? Okay, and now Tor does a slightly different thing. In Tor, what we want is I am trying to connect to a website. Let's look at I am trying to connect to a website. Now, when I am accessing a website knows that from where I am connecting. I don't want the website to know from where I am connecting or I am accessing the information. How to build up such a system? And it's a TCP connection. So I have to create a TCP connection through multiple relays in between. And there is one node and which then on my behalf connects to the server. So this guy will always see this IP address as the person who is connecting, not this particular client. Okay, so the communication will still go. So none of these, the traffic analysis, if you are a network operator and you know about the traffic, you won't be able to figure out that this is communicating to whom, how these pipes are being connected. So there is a pipe which is being connected. Okay, so there are interesting things which can be done with this pipe. So we will discuss them in the next video.